Hello, this is part 5 of 4.1. Even and odd functions is going to be covered here. Short little video. Okay, so take notes. This is 4.1 basic graphs. This is part 5, the last part in the series. All right, and hopefully you are checking in for attendance, even odd functions. Okay, so let's just recall what even functions are. So maybe you learned about even and odd functions in a previous math class. So even functions, it turns out that if you do f of negative x, then whatever you get when you plug in negative x, you get the same thing when you plug in positive x, okay? And this is true for all the x's, not just for some. Okay, so for all x in the domain. All right. And it turns out that for even functions, the graph is symmetric. Graph is symmetric about the y-axis. So maybe you recall learning about even functions and like the parabola f of x equals x squared. That would be an example of an even function. F of x equals x squared. This is an even function. And I mean, you can even check with just a few values. So like even if you do positive 1, right? F of 1, well, you plug in 1, you square it, and you get 1. And if you do negative 1, you plug that in, square it, and you also get positive 1. So this is what they mean up here when they say f of negative x equals f of x. So here, whether you plug in positive 1 or negative 1, you always get the same result, okay? And it says here that's going to be true for all the x in the domain. So whether I plug in 1 and negative 1 or 2 and negative 2, when I plug in 2, when I plug in negative 2, I'll get the same result. If I plug in 3 and negative 3, I'll get the same result, okay? All right, and we know what the, here, let me just write those down as well. So you can check it for 2. 2 squared is 4. If you plug in negative 2 squared is also 4. So you see, whether you plug in the positive or the negative, you're going to get the same result, okay? And when we graph this, we get 0 here, 1 here, negative 1, 1, 2, 3, 4, 2, 4, negative 2, 4. So here they're saying that the graph is symmetric about the y-axis, and we do see that. We see that here's the y-axis, and we see that it is symmetric, right? The right side mirrors the left side, okay? All right, so let's see here. Okay, so in terms of trig functions, it turns out that cosine and secant are the only ones that are even. Okay, so and that makes sense. So let me write this down. Trig functions. We know that the ones that are even are going to be the cosine function and the secant, which is the reciprocal. Okay. And that makes sense because remember when we look at the signs in each quadrant for cosine, we know that cosine is positive here, cosine is negative here, cosine is negative here, and then cosine is positive here. Okay, so whether I'm talking about positive 30 degrees, right, If I'm talking about positive 30 degrees, cosine of positive 30 degrees will be square root 3 over 2. If I do cosine of negative 30 degrees, it will also be positive square root 3 over 2. So we see here that the cosine and the secant functions are even functions, right? If I do cosine of 150, I'll get a negative. And then if I do cosine of negative 150, I will also get a negative, okay? Whereas if we do take a look at sine, I'm just going to draw this. You don't have to copy this. Okay, sine is positive here and here, and then sine is negative here and here. Okay, so we can already see right here, sine of 30 is 1/2, but then sine of negative 30 is negative 1/2. Okay, so we see that they aren't going to be the same when you plug in positive 30, negative 30. Okay, all right. Let's see. Okay, so when we look at the cosine graph, we know that it looks like this. So from 0 to 2 pi, we know it's 1 here, halfway in between is -1, and then 0 halfway on the left, halfway on the right. And so we know it looks like this. But if we extend it this direction to -2 pi, then we see that we get the exact same graph, right? Because it repeats. And so over here at negative pi, it'll be -1, halfway between 0, halfway between 0. And so we see that it is symmetric about the y-axis. Okay? All right. And so, and again, up here, we see that like if you do f, here, suppose that f of x equals cosine x. We see that f of pi over, let's do pi over 6, pi over 3. Let's do pi over 3 is cosine pi over 3, which is 1/2. And if I do cosine of negative pi over 3, I get the same thing. So that's what we mean by an even function. We get 1/2. You can't really see this here. Getting a little crowded in there. Okay, 1/2. Okay, so whether you use positive pi over 3 or negative pi over 3, you get the same thing. Okay. All right, so odd functions. Okay, so here for the odd function, these are, okay, so odd function, f of negative x equals negative the opposite of f of x. Okay, so they aren't equal like even functions for all x in the domain of f. Okay, and here the graph is symmetric about the origin. Okay. So one example is x cubed, the x cubed graph. Okay, so this here is an odd function because if we do f of 1, we get 1 to the third power, which is 1. But when we do f of -1, we don't get the same thing. We actually get the opposite. And so that's what makes it an odd function. And this happens for all x. I'll just do one more example with the number 2 and -2. If we look at f of 2, 2 cubed, we get 8. But if I look at -2, I get -2 cubed, which is -8. Okay, so we see we don't get the exact same thing. We get the opposite. Okay, so when we get the opposite, then we have an odd function. Okay, and the graph here looks like this for x cubed. We get 0 there, 1 here, 1, 1, and then -1, 1. Okay, so this is what they mean by, and then if you do 2, let's pretend that's 8, and this is -8. Okay, so so this is what we mean by uh, symmetric about the origin. Okay. All right. So the odd functions, in terms of the trig functions, the odd functions would be all the other ones. So that would be sine, cosecant, tangent, and cotangent. Okay, all of them. So the only even ones are cosine and sine. Okay. And again, that makes sense because when we did the graph for sine, right? Well, not the graph, but when we looked at it, sine here was positive, sine here is negative, positive, and then sine here is negative, and sine here is negative, right? So we can already see that if I do 30 degrees versus -30 degrees, here I'll get positive, but here I'll get negative. And the same thing, like if I go to 150 degrees versus -150 degrees, I see that here I'll get positive, but here I'll get negative. Okay, so we see that we'll get opposite signs, right, when we do sine of x versus sine of -x. Okay, I think that is it. And then, of course, the same logic applies to cosecant because cosecant is the reciprocal. And the logic applies to tangent because tangent is sine over cosine, right? Okay. All right, so that is it. So when you are evaluating, so here, let's do this. When you're evaluating, but you probably have them already memorized. So, so if you do something like this, if you do the sine of, let's do 135 degrees. Okay, so what sine of 135 degrees, that's going to be square root 2 over 2. But if I do sine of -135 degrees, right? That's the same as doing the negative of sine of 135 degrees. That's all they're saying with these odd and even functions. So that's going to be negative square root 2 over 2. But like I said, you probably have these already memorized. So trying to evaluate these in terms of odd and even, it's just another way to look at it. But if you already have these memorized, like, oh, sine of 135, I'm in quadrant 3, so that's going to be negative. That's fine too. Okay. All right, so that is it with 4.1. Good job on making it through all 5 videos.